Hello, third graders. So we're on our second week of learning about current electricity. Static electricity is a buildup of charge. Current electricity is electricity that flows. After you finish watching my lesson, I want you to watch these things on BrainPop. I want you to watch the video called Current Electricity and the one that's called Electromagnets, okay? So now I'm gonna show you a few things with some batteries and wires, motors and light bulbs, and show you some different circuits, open circuits, closed circuits, and then we're gonna go back to the PhET website again. All right, let's take a look. Okay, so third grade Cougars, we're going to talk some more about current electricity. I have a battery here, and it has a negative end of the battery and a positive. So the flat end is a negative, and this point that sticks up a little bit, that's the positive. So there's the positive sign. And I have a motor here. Now, the motor is connected to a wire, and the wire is metal. Metal is a conductor. It conducts electricity. It passes it on. Now, if I want to have this motor go, in order for the electricity to move, it has to have a closed circuit. So here's my battery. I'm going to touch the end of this wire to the end of the D cell, and I can touch the wire. It's no big deal. This battery does not have too much electricity. The electricity that comes out of the walls in your house is too strong. Do not ever touch that with any piece of metal. Now, I'm going to put the other end of the wire to the other end of the battery. And there we go. My tape was hitting the wire. So I have a closed circuit. And because I have a closed circuit, the electricity flows. It leaves the negative end of the D cell. It travels through the wire, through the motor, back to the positive end of the D cell. And now I'm going to take off one of the wires. As soon as I open the circuit, the motor stops working. Because the only reason that the motor is working is because the electricity is flowing through it and causing something to happen in the motor to make it spin. So again, this is a closed circuit. This is an open circuit. This is a closed circuit. This is an open circuit. Now, I could find out other things that might conduct electricity. So I have a fork, and look, I'm not even touching the battery directly. By touching something that is metal, I'm able to conduct the electricity. It's still a closed circuit. Okay, now try this. I'm going to try some tape. I'm going to put the tape here, and I'm going to put here. The motor does not work because tape and paper are not conductors. They are insulators. They do not pass the electricity on. The fork, great conductor. Plastic, not a conductor, it's an insulator. Okay, so now we know that the battery is where the energy is stored. We know that metal is a conductor, and we know that plastic is an insulator. That's why the outside of the wire is covered in plastic. That makes sure all the electricity stays inside. All right, Cougars, so now what I'm going to do is I'm going to show you a few other things about circuits, electric circuits, and current electricity. This is something called a circuit board, and there's all these great little things that help you put your materials in here, and that way you don't have to hold everything together. So this is a battery, or a D-size battery, D cell, and this is really awesome because there's metal And we just learned that metal is a conductor, right? So when I put the battery in here, it touches the metal and then it can pass the electricity on. So I'm gonna put the battery in the D cell, and this is a switch. So normally, like when we turn a light on or off, there's a switch on it, right? And this is exactly what a switch is like. A switch closes the circuit. Okay, so I'm gonna use the switch, and I'm gonna start with the motor, and the motor has the wires. I'm gonna use these little clips to connect the motor to the battery and to the switch. And I'm gonna close the switch, I'm gonna close the circuit. My motor's not spinning because I actually don't have a closed circuit. I still have this area open. So that part of the motor is not, of the circuit is not closed. I need another wire. I'm gonna take a wire and I'm gonna go from the switch to the other end of the battery. And you can hear it spinning. And can you see it spinning? It's spinning around. So now my motor is working because I have a closed circuit. I have a closed circuit. Now, if I open the circuit, my motor doesn't work anymore. Close the circuit, and my motor works. And if I use my fork, which is made out of metal, I can help close the circuit, and it works. But if I use plastic or tape, does not close the circuit because they are insulators. Okay, so I have a circuit. It leaves the negative end of the D cell. The electricity is negative charge, so it is repelled out. It goes through the wire, through the metal, through the wire again, and to the other end of the D cell. This is a complete circuit, a closed circuit. That's an open circuit. There's an opening so that makes the electricity stop flowing. Okay. All right, so boys and girls, we're back at the PHET website, P-H-E-T. It's from the University of Colorado Boulder. We're going to go to simulations. We're going to click down to by grade level. We're going to go to elementary school. We're going to go down to circuit construction DC. DC means direct current. I'm not going to download it. I'm just going to play it. Okay, so now I'm going to go back to the intro. And again, the battery is the source of the energy. That's where the electricity will come from. The wire is made out of metal. So the metal is a conductor. And I can stretch it, move it around. I'm going to use a light bulb as my piece of equipment that will use the electricity. I'm going to put another wire here, and I'm going to connect it here. And we can see that we have this is a complete circuit. This is a closed circuit, and we can see the electricity flow. Okay, great. So I'm going to cut that open. This is an open circuit. Okay, so boys and girls, there's another couple of ways that we can make the light bulbs light up more. And one of the ways is to increase the batteries. You have more batteries, you have more power. So I'm going to use a wire. I'm going to put a light bulb here. You know what I'm going to do? I'm going to put my light bulb up above. I'm going to move my batteries down a little bit. And I'm going to get another wire. And I'm going to connect it to this circuit. Oh my gosh, look how fast those electrons are moving in that circuit. So boys and girls, this is one way to make the light bulb brighter. Now, this is kind of fun. And it's fun to do this on a computer simulation because nothing terrible is going to happen. Wow, super fast. I'm going to spread this out a little bit more. I wanted to find out how many batteries I can put in. Wow, look at that. Look how fast. I'm just wondering if it would ever get to a point where the battery, where it would set it on fire. I don't know. But look, the more batteries you put in a line, in a series, the faster it will go. Okay, so boys and girls, I want you to keep playing around with this website. Again, it is a circuit. You can see the electrons flowing through the wire. The wires are conductors. The light bulb transforms the motion of the electrons into light and heat. And then the electrons are attracted back to the positive end. So they're repelled out of the negative end, and then they are attracted to the positive end. All right, have fun with this PhET website. Next week, we're going to start talking about solar energy.